Hello students, welcome back to our channel. Today we are going to discuss about plant population, how to calculate plant population and what is its significance. Plant population, how to calculate this plant population and what is the significance of maintaining plant population, optimum plant population in a field, right? Plant population means in unit area how many number of plants are there. In unit area, let's say we are taking 1 acre of land or 1 hectare of land, how many plants will be there in that particular area. So what is the significance? When we sow the seed or when we plant any sapling, we maintain some specific distance. That means we maintain the row to row spacing, that must be in centimeter. If we are taking large plants like plantation crops, then we can take it in meter. Then plant to plant spacing we are maintaining. Yes or no? So let's say this is the row to row spacing, right? And this is the plant to plant spacing. Let's say here we are showing one seed, another seed here, another seed here. So this is plant to plant spacing. So why this is important to maintain this spacing? To avoid, suppose we are planting one seed here and we are placing another seed here. If we are closing the gap between two plants, and this spacing is decided by their canopy coverage, right? So if this spacing between the plants and between row to row, that is decided by the canopy coverage. So that if there is a optimum spacing, let's say 30 centimeter, that is decided, right? If we are going for spacing of 20 centimeter, so we are narrowing down the spacing. So their canopy, they will touch each other, they will cover each other, they will compete for space with each other. So here the intra-plant competition, intra-plant or intra-species, because this is between the same species, right? So intra-species or intra-plant competition will be higher. For what? For different resources. So we should not go for closer spacing than the optimum. Let's say this is the optimum spacing, 30 centimeter. If we increase the spacing up to 45 centimeter, then what will happen? Then the canopy coverage will be sparse. So directly sunlight, it will fall on the ground. So we are not harvesting maximum sunlight. Our main aim in agriculture to harvest maximum sunlight and to convert that solar energy to chemical energy, right? To organic form by photosynthetic activity. So we are here, the solar radiation efficiency is reduced. So we are not optimally utilizing the solar radiation, that is a resource for in our agriculture, right? So we are not optimally harvesting that solar radiation. So this is the main reason why we need to maintain an optimum spacing, right? So there is a relation between plant population and versus yield. There is a relation, simple relation between plant population and yield. It was proposed by Holliday in 1960. So he proposed two laws. Okay, one is probabilistic relationship. Okay, no, that is okay. Yes, one is parabolic relation, another one is asymptotic relation. This relation is between plant population and yield. So in parabolic relation, what happens? Suppose this is yield and this is plant population. So as we increasing the plant population, the yield will increase, then it will reach at maximum, then it will decrease. Okay, so this is the plateau level up to which if we are increasing the plant population, the yield will increase. Then after that, after reaching this plateau, the yield will decrease. So most of the crops like rice, wheat, this parabolic relationship you can observe, right? Then another one is asymptotic relationship. What happens here? Here this is plant population and this is yield, right? So here if we increase the plant population, the yield will increase, go on increasing, and it reaches the plateau and it remain constant. It is not decreasing. Okay, the yield is remaining constant, it is not decreasing. So in mostly the forage crop or fodder or forage crop, you can find this asymptotic relationship. Why? Because in fodder crop, the total above ground biomass, that is economic part. In fodder crop, what is the economic part? The biomass that is fed to cattle, that is the economic part. So in fodder crop, mostly the total above ground biomass, whatever we are getting, that is the economic part. But in grain, cereal crop or pulses crop, the grain is the economic part. So grain yield will be reduced after certain point. After reaching the plateau, the grain yield will reduce if we are increasing the plant population. So this is the relationship between plant population and yield, and it was propounded by Holliday. Now, how to calculate the plant population? Let's say this is 1 meter square area. This is 1 meter, this is 1 meter, and the spacing is given. Let's say spacing is 30 centimeter into 10 centimeter. So how to calculate how many number of plants are there? Okay, plant population basically is a function of spacing. Okay, plant population basically a function of spacing, right? So how to calculate this plant population? So you need to, in numerator, numerator you have to place the area, that is 1 meter square, divided by spacing. Spacing is in centimeter, so you have to convert it into meter. So 30 by 100 into 10 by 100. So it will come 100 into 100 by 30 into 10. Somewhere I think, okay, somewhere 33.33 or 34 plants will be there. So this is how you can calculate the number of plants per meter square if spacing is given, right? And it is utilized, where it is utilized? To calculate the seed rate, to calculate the yield, estimate the yield, estimated yield. Okay, for this calculation we will talk later on. This plant population is essential. Okay, and in this particular lecture we saw that what is plant population, what is this, what is optimum plant population, what happens if we are not maintaining optimum plant population, and what is the relation between plant population and yield, and how to calculate plant population. If you have any doubt regarding any concept of agronomy, you can ask me in the comment section so that we can cover it.